Thank you, everyone, for joining this session on building an open source data strategy on AWS. Let me start by telling you a story. This story is about an organization, much like the ones you and I work for. This organization faces a major challenge. Their data is growing exponentially, scattered across different departments, with no unified system to derive insights from. This leads to a lot of inefficiencies. Inefficiencies that not only cost them money, but missed business opportunities. As your data grows in volume and variety, businesses without the right strategy in place to manage the data can find the situation overwhelming and unmanageable. Now, does this story sound familiar? Can I see some hands, please? Turns out, this organization is not alone. Studies suggest that although data-driven organizations can make 20% more money, yet only 1 out of 4 of them can turn data into strategic assets. This is where the power of using open source technology in the cloud comes into play. Using open technologies and frameworks, coupled with the flexibility, agility, and efficiency cloud provides, can help you build a data strategy to manage data across disparate sources and separate departments. Ladies and gentlemen, my name is Sandeepan Bhaumik. I'm a Senior Analytics Solutions Architect at AWS. And today I will walk you through how you can build a data platform using open source software on AWS. We want to make sure that data is not just a byproduct of your business, but it's a cornerstone for your growth and success. And I'm sure you're here to hear about real-life stories, tips from experts who have been there and done that. So I'm happy that Zohar from Tessian will be joining me later in this session to walk you through how they have built an end-to-end data platform using open source software on AWS. Let's get started. Open source has revolutionized the world of software engineering. We know our customers are passionate about running open source in the cloud. Open source gives you the transparency. You can look into the code base. You can see what is happening under the hood when you use open source software. It gives you the flexibility to extend that technology and use your own customization, build your own software layer on top of open source. And it helps you leverage the power of communities when you use open source software. However, when you run open source in the cloud, if you self-manage open source technologies in servers and infrastructure that you are responsible for, it adds a lot of operational overhead. And these operational overheads takes your focus out of delivering business value, and you end up spending time and money in managing infrastructure. Now, when we build open source technologies to be operated in the cloud, we make sure that it's easy for you to set up and deploy them. We build robust security controls so that we can protect you against threats. We make sure these softwares are scalable so that you use resources that can go scale up and scale down as your business demand changes. And we make sure we minimize downtime by applying high availability techniques at the infrastructure level. We are making upgrading and deploying of this software easy to simplify your IT tasks. And we make sure that you can leverage a pay-as-you-go model so that your expenses are frugal. Now, when you run open source in the cloud, there are two things that you need to think about. AWS's collaboration with open source technologies, it has been substantial. We are one of the top contributors in open source technologies. We have been doing that for years now. Apart from the 1,500 Amazon GitHub repositories that we have open sourced, we also contribute to thousands of third-party open source projects. We have contributed to technologies like Apache Hadoop, Apache Spark, Kubernetes, Docker, MXNet, to name a few. We are also contributing to the Rust Foundation, bringing innovation in the Rust language. And we fully operate and manage the OpenSearch project that powers the Amazon OpenSearch service to provide scalable search, log analytics, and vector database capabilities. Now, when you run open source in the cloud, you will find two models on how you operate open source softwares: the managed open source model and the open source compatible model. In the managed open source model, we take the open source software, we package it and deploy it in an infrastructure that you might have direct access to. For example, Amazon EMR, Amazon Elastic MapReduce service, is one of those services where you could actually take the EMR software and deploy it in EC2 instances that you can directly manage. We make it simple for you to upgrade this software, to use it and set it up, but you can still have some control at the infrastructure level. What we also make sure in this model is that we have close currency with the open source release cycles. For example, in EMR, if you're running Spark, we make sure that we maintain currency of 30 to 60 days when new releases come in the open source ecosystem. And this allows you to leverage the latest innovations as the open source community introduces them in the open source release cycle. Amazon OpenSearch project, the OpenSearch project, the open source OpenSearch project is a great example where you can take that project and deploy it into EC2 instances, manage it yourself, or you can leverage the Amazon OpenSearch service that takes away the undifferentiated heavy lifting under the hood and makes it easy for you to use that. On the open source compatible model, you are basically using an AWS native service. But what we do is we enable a link to use a client library which is open source. In this case, we fully manage the open source, the service. We manage the deployments and upgrades and everything. You do not have direct access to the infrastructure. This typically runs in our service accounts and can be exposed to your VPCs at the network layer through private links. But all you get is an AWS service and link to use the open source software through that service. Amazon Document DB with MongoDB compatibility is one such great example. And Amazon Key Spaces with Apache Cassandra is another example where you can actually link to these open source client libraries and start using those engines from the AWS service. Now that I have told you about these two models, I want to break down one of these open source software for you and see how, and show you how it is architected on AWS. I think it is important for you to know when you run open source software in the cloud is where you are touching the open source software when you operate them, and where you are touching things that AWS runs and manages. Let's dive in. When you use open source software on AWS, let's take an example of like Amazon EMR, as I mentioned earlier. We typically tend to divide the architecture in two planes, the control plane and the data plane. The control plane contains the service endpoints, and it supports APIs that you would interact with the service endpoint to provision the software. So if you're using EMR and installing Spark, you can use these APIs from AWS API, CloudFormation, or Terraform to provision these services. That's the provisioning part. And then there are functions within the control plane that control what happens within the open source service. And these functions can run on AWS Lambda, or they could run a bunch of service fleets for long-running tasks where we terminate those APIs onto. And these functions are paired up, and they interact with the data plane. The data plane is where your data resides. This is where you interact with the open source software when you are using it. Now, the core to the open source service is what we call the open source software image, or OSS image. You get, if you use Apache Spark in EMR, you get a Spark image, what we call EC2 Amazon Machine Image, AMIs. And that's the default image that you get. But we give you the flexibility to customize that image and use a custom AMI. So you take the open source default, add your own software layers, use your custom libraries that you would want to, giving you the flexibility to customize the software. This OSS image then gets applied to a bunch of capacity pools within the data plane. These capacity pools give you the scalability, so they can auto-scale, go up and go down depending on your business demands. Now, this capacity pool can take various forms. It can be EC2 instances, Kubernetes pods, Fargate containers, Docker containers, etc. But ultimately, they yield a service instance endpoint. The service instance endpoint is where you get an IP address to interact with the software. And you interact with that from the service client, which is generally an open source service client. And what it does, if you're using JDBC connectors, it will use JDBC connectors to connect to the service endpoint. If you're using graph databases, it will use Gremlin. If you're running Spark, it will use the Spark submit to run Spark for data processing jobs on the data plane. Now, you see how we control the open source software in the control plane and give you flexibility and scalability to customize it, and support auto-scaling at the capacity pool that we provide in the underlying layer. We optimize these OSS images for performance as well. So this gives you a holistic, you can leverage this holistic strategy of optimizing the software, implementing scalability, and having that flexibility to customize it. Now that I've given you a picture of how open source softwares are architected on AWS, I will show you how you can use different capabilities that we provide in the data and machine learning and databases space to build an end-to-end data strategy. Here, I will map out the capabilities, starting from data storage. On data storage, when you start building your data lake on Amazon S3 simple storage service, we support open file formats and open table formats like Parquet, Apache Iceberg, open source Delta Lake, etc. Once you've done that, you want to catalog your data, you can use AWS Glue Data Catalog, but we also support open source Hive Metastore, where you can extend Glue Data Catalog to refer to the Hive Metastore and get metadata from there. We also support Apache Knox and Ranger within Amazon EMR that would help you configure fine-grained access control and govern your data. When it comes to data processing and analytics and exploration, we support a bunch of open source software within Amazon EMR. So if you want to do SQL, your business analyst wants to run SQL, you can use open source Trino. You can, again, use Apache Hadoop and Spark and some of the other open source software. If you want to go with the managed service with Amazon Athena, you can still run SQL and leverage properties of Trino and Presto that are built under the hood within Athena. If you're dealing with streaming data, if you want to store streams, you can use open source Kafka through Amazon managed service for Kafka. And you can also use stream processing services like Apache Flink within our managed Apache Flink service. With the OpenSearch project, you can build search and analytics applications with that software. When it comes to databases, we support a range of open source relational database engines like MariaDB, MySQL, PostgreSQL, MongoDB compatibility with Amazon Document DB for NoSQL, as I mentioned earlier, Cassandra in key spaces, and a lot of other purpose-built databases that are either managed by AWS in the open source compatible model or supporting open source engines for you to run your database workloads on. And then in machine learning, you can use AWS deep learning AMIs, deep learning Amazon machine images. And these deep learning AMIs are basically EC2 instances pre-installed with either PyTorch, TensorFlow, Keras, MXNet. So you can just launch EC2 instances pre-installed with those open source software and start leveraging deep learning workloads. You can also use Amazon Bedrock to call open source LLMs like Claude, Stable Diffusion, etc. For developer experience, a notebook experience, we support Jupyter Labs in an open source format, but we also integrate that with our integrated developer editor like Amazon EMR Studio, SageMaker Studio, and Glue Notebooks. AWS Professional Services open source the data.all project that helps you build data marketplaces and build the business glossaries and business data catalog on top of your data. And then in the observability space, we provide managed services with Prometheus and Grafana. We support Apache Airflow through managed workflows for Apache Airflow for orchestration, and we support infrastructure provisioning through Terraform. Now, this gives you a map, the capabilities that you can leverage in open source software to build your end-to-end data strategy, right from operational processing to analytics processing to machine learning. Now, I will hand over to Zohar from Tessian to walk you through a real-life story, how they have built a data platform, and what are the lessons that they have learned while using open source on AWS.
Thank you, Sandy. Hello, everyone. My name is Zohar Stiro. I'm the lead data engineer for Tessian, and I'm very excited to be here. I would like to share with you the journey that we made to define our data strategy using open source on AWS. But first, let me introduce you to Tessian. Tessian is a cloud email security platform. We help our customers to deal with email attacks. We use machine learning solutions to both defend against incoming inbound email threats and also to protect from losing sensitive data using emails. Tessian also provides tools for the end user and the admin to respond to those threats if they do encounter them. Tessian is a security company, and customers trust us with their data. We take this very seriously. In Tessian, we created processes, both from security and legal perspective, to investigate every tool we introduce into our platform. And this is especially true for tools that touch customers' data. Tessian is also highly invested in the AWS Cloud. We use security controls, such as role management, authentication, encryption, multiple environments, and multiple accounts to decide where data is stored and who can access the data. With that in mind, let us jump straight to the data strategy. The truth is, we had no data strategy. Let me take it back to how it was working in Tessian, a much smaller company around 4 years ago. We were in this hyper-growth scale moment. Every week, we would onboard or POV a new customer or a bigger customer. The teams were running fast, trying to introduce new features. The production state was basically on fire, and we had to keep the ship sailing. There was no time to stop everything and define our data strategy. The choices we made, given the limitation at every choice in the way, I believe was the one that shaped our strategy. And I would like to share with you those main choices we had to make. The first one, I believe, is familiar to you. When Tessian was a smaller company, we made a decision. We had one main Postgres database, an RDS database. This one main DB was powering all of our production flows. We were storing all of our statistics as well in there. We were storing customers' configuration there. And our data scientists and analytical workloads and ad hoc jobs were also on the database. I believe this decision helped us grow fast and move fast, but we started to feel its limitations where we started to scale. We even had a sort of date of death for the DB if we continued to scale in the same way, and we were actually using the biggest instance type at that time. So we need to make the obvious decision, I think, was to reduce pressure and offload some of the workflows from the database. The easy choice was to offload the non-critical workflows, the ad hoc access to the DB. At this point, we already had an export, a daily dump of the DB that we would put into S3. The problem of querying the data was that users had to join multiple tables together to get a view, a sort of understanding of the process end-to-end of an event. And that was non-efficient, and the queries were very long. So our decision was to pre-create a daily view of the data from the dump of the DB and expose it to our users. That was, in a way, the start of our data analytics on a data lake. The decision we had to make is what technology we'll use to create this view. I come from an experience, me and my team, we both come from an experience of managing Hadoop clusters and running Spark loads on top of them. And we decided to use this knowledge and experience in this technology and just use EMR, which is the managed Hadoop Spark in AWS. Once you have a workflow, which is a pipeline of jobs, first would be the export of the DB to the S3 bucket, then a daily job which would create the view, you need an orchestration tool. And for that purpose, we kind of decided on the same solution, use a technology we're already familiar with. We had experience with managing Airflow in the open source. And then we decided to use MWAI, the managed Airflow solution. That allowed us to schedule and orchestrate the pipelines end-to-end. This solution held pretty well, but its obvious shortcomings started to come up more and more. The main one, which is kind of easy to see, that we have a delay in the data freshness. From the moment an event was stored in the DB until it was available to query could be up to 3 days. Some time to export the data to the S3 bucket, and then a day of a daily job to create the view. Our next step in the evolution was to move to an event-based flow. The point behind it was providing the data much earlier to our users. And for the users who do want to see the merge of all the tables, they would still wait for a daily output of the job. The main difference here is that we didn't need to create the view from all the data each time. We could now use appends or delta from the last time we ran to update this view. The architecture at this point looks something like this. We had an incoming source, which would publish events to a queue system. We had a service that would stream those events to an S3 bucket. Those would be the data set that clients can access all the time. And then we had a daily job that would take the delta from the previous time it ran and update the final view. At this point, the decision we had to make was the technology which would be the queue system that we use. Here it was a mix. It was both, again, we had experience using Kafka outside of the AWS managed services. But also, we knew that open source tools integrate well together. When you use Spark streaming services, you can use Kafka as an input format, and it's very easy to set up. That was basically the reason why we went with managed MSK, which is the managed Kafka solution. The architecture we defined enabled us to access data much quicker, but whoever of you who had the chance, the lovely chance of migrating from batch to streaming, there is a new set of challenges that you need to take care of. The first one was when we were using the export of the DB, we would get a state, a snapshot state of the DB at that time. But now we need to keep updating the latest view. Updates are inherently as part of the database, but updates as appends to an S3 data set is something that is not supported. Apart from that, when you start streaming events to a dataset or to S3, you create many more files. Before it was one batch job which would output files. And now it was a streaming service that would create a file or many files every mini batch that it would run. The choice we had to make is, do we now create the functionality of updating our final view and creating a mini framework that would optimize those files as they come, keeping in mind consistency, keeping in mind how do we avoid corrupted data, or we use something that is already supporting it out of the shelf. Luckily for us, at the same time, EMR, the managed Spark solution, announced that they support Apache Iceberg. Iceberg is an open table format. If you would think about it, it's like managing your files on S3, but in a table way. Iceberg supports updates, deletes, or ACID operations as you do on databases. And Iceberg also comes with tools to optimize the data, optimize the metadata, and optimize the files that are written underneath. Our flow was basically similar, but now we introduce Apache Iceberg as a format. So we would stream the events to the tables using Apache Iceberg, and the final view that we would create would merge different tables and be able to use updates in that view. When you use Apache Iceberg, you need to define a data catalog with it. A catalog is a place where you basically define where your tables are stored, what is their schema, and some other properties that you can use. Apache Iceberg supports AWS Glue as a data catalog, and that's what we used. As a nice side effect, it enables us to use Amazon Athena. Athena is a query engine that allows you to run scalable SQL-like queries on top of your data, and it uses the same Glue catalog as a way to discover your tables as well. So by using Apache Iceberg, we enable the use of Athena for our users as well. The next evolution was taking these internal analytical end-to-end pipelines and exposing it to our external customers. We already had an end-to-end pipeline which was optimized, had fresh data, and we even had a layer of exposing the data using Amazon Athena. And that basically was our first version of providing an investigation product to our customers. When we were developing this solution, the main requirements that we're hearing, apart from accessing the data, was also the ability to full text search the data. And one more requirement was having a more interactive flow and a very low latency response times. We knew that Athena provides us access to the data, but a full text search on top of Athena with the requirements of the low latency will have its limitations. That's why we chose to use OpenSearch. OpenSearch comes with the built-in indexing abilities and provides you the option to full text search your data. As well, it has very fast response times. We use the same in Kafka that we were using in the previous analytical flows and connected a Python service that we built in-house, which would then publish those events to an OpenSearch. From the customer's perspective, the external customers would access a portal which behind the scenes would be powered by the OpenSearch. For the internal users, we exposed Amazon Athena. And for our data scientists, we're using Amazon SageMaker, which is the managed notebook solution to access the S3 buckets. They could run queries either from the notebook or use an EMR as the power behind the notebook to query the tables, and afterwards create their training pipelines and deploy their jobs. By building this platform, we managed to get under 1 second end-to-end time from the moment an event comes to our system until we flag it if it's malicious or not. The Respond product is managing to get 300 milliseconds of average response time. And the platform scales to up to 100 million of events scaled every day. During the time that we worked on those solutions, there were many lessons learned, and I would like to share some of the tips with you. I think the main tip is if you're managing open source outside of AWS or directly on AWS EC2, the movement to the managed open source has its learning curve. Every product has a different definition around monitoring, network, authentication, or how you add dependencies to that solution. One example I can think of is when we used MWAA, the Managed Airflow solution. They enable you, the monitoring, the metrics are being sent to CloudWatch. We are highly invested in the Prometheus stack, so for us, we had to create a custom flow to get those metrics from CloudWatch to Prometheus. The first one of the worries that we had when using open source on managed AWS was the life cycle, the release cycle of newer versions. The truth is, when you manage a critical production infrastructure, upgrading it is not an easy thing to do. And as we saw it, we're always behind the latest available version that AWS provided, and I can't recall a feature that we wanted that was not available at the time. When you use open source technologies, and some of them are not as mature, let's call it, as example as Apache Iceberg, some releases might have issues in them. We had such a situation with Iceberg when the ability to delete some data was not working correctly. We went to AWS support, and actually the service team backported a solution from the master branch back to a version that we were using. When you use open source in AWS, there are some extra features that are not available in the open source. In the Kafka case, the MS case supports tiered storage. Tiered storage is a way to offload from the EBS or the disk on the Kafka to an S3 bucket. This allows you to increase retention on some of your topics, which in turn help us to reduce the criticalness of some of the flows. We could wake up the next morning and fix an issue because we had enough data stored instead of jumping in the night. We found that open source managed solutions work very well with native AWS solution. That was the case with Amazon Athena, and that was the case with Amazon SageMaker. During the work, we also had AWS announced support for serverless solutions, such as Kafka serverless and EMR serverless. And we are now investigating into how we can utilize those serverless solutions to reduce the overhead of managing some of the clusters in staging and testing environments. And lastly, with security. All of the open source products support IAM roles access, multiple environments deploy, encryption keys, including customer keys, and that helps us to retain the same security control that we were using. I'm excited to share that Tessian was acquired a few months ago by Proofpoint. And Proofpoint is a different scale and different amount of customers. I am confident to say that the platform that we built will be able to accommodate these growing needs and different scale. And I am confident to say that this will be probably the next evolution in our data architecture. To reiterate our data strategy, we used familiar products that we have experience with. We chose frameworks that integrate well together, and we decided to use the right tool for the job, which sometimes was just the easy thing to do, like with OpenSearch and with Iceberg. I would like to hand it back to Sandy to cover some more architectural patterns that customers use.
Thank you, Zohar. Isn't it beautiful to see how organizations can evolve their architecture as the business needs changes and their data strategy evolves? Using familiar technologies, using the right tool for the right job, and leveraging the seamless integrations that we are building with open source software on AWS and AWS managed services gives you that flexibility. Let me go through a couple of architecture patterns. I started with the story of data across different departments without any unified system in place to derive insights from. And I want to close that off, giving you some ideas on how you can build such patterns. There are many patterns that you can build. We'll go through one. The key when you think about data strategies is building your ingestion strategy. You will have data from various sources. You need to use the right tool to start ingesting data into your data lake. Zohar talked about how they build the data lake with S3 and Iceberg to support transactional support. But what you can also do is, if you're using open source Hive Metastore, you can migrate that to EMR directly and start building your data catalog in Hive Metastore. And we extend support with AWS Glue Data Catalog to catalog the data and connect to your Hive Metastore while you use AWS Glue Data Catalog as the front end. And we have also integrated Glue Data Catalog with AWS Lake Formation, which not only provides cataloging solutions, but allows you to access control at the cell level. Now, what Lake Formation also provides is the ability to share your data catalog across AWS accounts in the same region or other regions. And that means as you start building this data catalog, you can share this catalog with your internal teams in different AWS accounts or in the same account, with your customers who might be sitting across geographies, without moving the data out of S3. You are not actually moving the data into these other consumer accounts. And what that also means is that consumers now get a place where they can go and search for the data. They can discover data. They can request access for that data. And then use tools like Athena if there are, let's say, data analysts who would want to run SQL, and bring the right tool that they want to use to do their job. Maybe another team would want to use EMR for data engineering or SageMaker for machine learning. They can bring the tools that they want to use. This gives you the capability to start building your data catalog that then you can expose to consumers where they can discover data and gain access to data. Now, you can also leverage the managed solutions with open source software. You can also go directly with AWS Glue Data Catalog and Lake Formation. Now, AWS Glue Data Catalog will provide you the technical metadata catalog. If you want to add business glossaries, you can use data.all, which I mentioned about in the data strategy slide. You can also explore managed services like Amazon Data Zone that provides these kind of capabilities to take your data governance capabilities to the next level. I think I deserve an applause here. I managed to talk about through this session without uttering the word generative AI. But I wouldn't let you go without talking about generative AI. Right? I think this is really important. Generative AI is revolutionizing every dimension of life that we touch. What is generative AI? It's basically AI generating content, leveraging large language models. These large language models are built on huge amount of data, trained on billions of parameters. But what use is that if you cannot add your business context to it? Where is your edge if you cannot use generative AI applications that understands your business data? That's where patterns like retrieval augmented generation come in. And so it's turning out to be a very popular pattern across our customers as well. With retrieval augmented generation, or RAG, you can basically add business context from your data stores, data that you have stored in your data lakes or your databases, to your generative AI applications. So that when your customer writes, you provide customer support through a generative AI application, and your customers ask questions, the application already has context about the customer. They know who the customer is, what are the customer details, etc. Now, I will not go through all the concepts here. You can scan the QR code, and there's a blog that explains that in details on how you can implement this solution. But the reason I wanted to put it up in this session is because when you use RAG patterns, you use patterns like, you'll use data stores like vector databases. These vector databases store data in a vector dimension that helps with semantic search. So semantically similar data will be stored together in these data stores. That makes it faster for the generative AI application to search for the context and throw it back to the user. When it comes to open source, in AWS, we provide 3 database capabilities that you can see at the top in the box. Amazon OpenSearch service that provides vector database capabilities, and the PG vector extension of PostgreSQL that you can leverage from Amazon Aurora or Amazon RDS. Something else that I want to point out, the generative AI application is one box at the left. If you look at the other stuff, it's all data. You need to think about your data strategy to leverage generative AI application. If you want more information, there are 2 QR codes that will give you access to more resources on open source technologies on AWS and analytics services on AWS. Please feel free to register on Skill Builder and get access to a number of free learning courses to build your AWS skills. And as I close this session, I want to leave you with a thought. Generative AI is going to change every organization and every business. The differentiator you build is with your data. Your data is your differentiator. And having a data strategy in place is the first step to go and become a data-driven organization. With that, I hope that the insights we shared in this session will be the catalyst to bring innovation in your organization. We'll be around for some time. If you have any questions, please feel free to ask us over here. You can find me in the AWS for Data booth in the afternoon as well. We are doing some good demos over there, RAG patterns, generative BI, etc. Please feel free to swing by. And thank you very much for your time. I hope it was useful.